Okay, I think I'm good to go. Good afternoon, everyone. My name is Andy from the company Croit, and I'm happy to be here today and talk to you about block storage protocols, a little comparison across them in Ceph. The title of the talk, From iSCSI to NVMe-of Fabric, a comparative look on storage protocol advantages and challenges. A little bit about myself. Background is in computer science, like some, 23 years ago. Since then, I'm in IT functions in different companies. In Germany, different roles, different responsibilities, self-employed since 2013, currently managing director of Croit and being part of that company in different roles since 2017. Who is Croit? I don't know if you heard about us, if you know us. We're a company headquartered in Munich with a subsidiary in the United States, founded in 2017. Team of 25 colleagues around the globe, growing. The next one will join us in January. We are bootstrapped. We are growing nicely since we exist. We've been awarded with the Deloitte Technology Fast 50 2 times, and we are currently focused mostly on Europe and the United States. What is it what we do? You can see it a little bit on the right. We started around our core product, which is a deployment and management software around Ceph. Over the time, we integrated DAOS as well as another software-defined storage technology. And around this, we provide services like consulting, professional services, support, training. Since a few months, we are also active, or more active with Proxmox, offering this to our customers, doing trainings, doing consultings around that. So that's a little bit about us. Maybe also noteworthy, we are a part of the Ceph Foundation. We're one of the founding members. We're actively contributing to Ceph with 2 of our colleagues. And yeah, we're happy to be part of that ecosystem. Before we dive in, so we want to talk about block storage protocols in Ceph. I don't want to take all the credit for this presentation. It was suggested by a colleague who cannot be here today, and it was supported by other colleagues from our company, from support, from engineering. So I want to thank them as well. And having said that, let's start. As we compare RBD, iSCSI, and NVMe-of Fabrics, we want to talk a little bit about where are they coming from, what is the history, what are they, a little introduction. Then I selected a few things that we can compare them on, like performance, reliability, scalability. That is a little bit handpicked based on our experience and what we see, the discussions we are having with our customers. I'm also sharing a few customer insights that is more around what we see about NVMe-of Fabrics. And at the end, if we compare it, we might also try a conclusion, which is, you'll see. Okay, let's begin. You know all the protocols that are available in Ceph. Today, we are focusing on the lower 3, RBD, iSCSI, and NVMe-of Fabric. And iSCSI is the first one I'm mentioning here. It's Ceph native block storage protocol. Development started around 2008, 2009 as part of the Ceph project, and was released, as far as I know, with version 0.48 in July 2012. So it's the medium-aged one of the 3. It allows thin provisioning, resizing of volumes. It's highly scalable. It's probably the well-known go-to block storage protocol in Ceph. It supports snapshots, clones, and replication. It integrates well with a lot of virtualization, container, or other orchestration platforms. Has a nice adoption rate among our customers. iSCSI is the oldest one we are comparing here. It's kind of the industry standard for block storage over IP networks. I should probably also at Fiber Channel here. It was developed like, I don't know, a quarter of a century ago, around 26 years ago, started the development. It was standardized by the Internet Engineering Task Force around 2000. First introduced in Ceph with Luminous in August 2017. And as it's very, I don't want to say old, but mature, it is well supported among very different solutions in the market. It supports clustering, it supports multipathing for redundancy. But when we look on the Ceph side of iSCSI, it's also kind of end of life. The feature development stopped November 2022. Since then, it's in maintenance mode, but I guess we won't see any updates there or new features. Last but not least, NVMe-of Fabric, the youngest one. Development started, or it emerged around 2014 as a protocol to extend the NVMe-of protocol over high-performance network fabrics. First officially specified in 2016 and supports different networks, TCP, Ethernet, Fiber Channel, InfiniBand, and Ceph integrated it in 2018-19, around that time. First kind of production-grade release was in 2020, so it's the youngest one. And if we look on these different protocols from a high-level architecture point of view, we have iSCSI on the left. Oops, it's too far. iSCSI on the left, NVMe-of Fabrics on the right. They look very similar. So architecture-wise, they depend on targets, they have initiators, they have gateways, and they provide the targets to clients on top of the Ceph RBD stack, which I have here for the matter of completeness as well. Looks different, is the underlying layer below iSCSI and NVMe-of Fabrics, but they look pretty same on a high level. But there are differences and similarities among these. RBD is, as you probably all know, it's a very much decentralized approach. We have no gateways other than in NVMe and iSCSI. We need gateways to support them. They are very similar on the high level, but they are different under the hood. If we look at iSCSI, it's an old protocol. It's based on pretty much standard TCP, an implementation that uses a lot of kernel space mechanisms, all very well known. NVMe-of Fabrics, in contrast, it's a much more modern implementation. It's based on SPDK, the Storage Performance Development Kit, and runs mostly in user space. It has much less kernel space interaction. It uses polling instead of an interrupt-based mechanism to reduce latency. That's probably one of the interesting differences here. It also leads to a high CPU utilization. Usually it locks a core or is pinned to one of the CPU cores to have it exclusively to do the polling and have a guaranteed responsiveness. It's compared to iSCSI, a more lightweight implementation. It supports other protocols like RDMA over RoCE or InfiniBand. And if I'm not mistaken, there is a development also providing an interrupted NVMe-of Fabric as well, so something that might be less consuming on the CPU, but probably also not that much performant. I found a merge request on this topic today, but I don't know what the actual status, if it's somewhere in a product yet or not. So high level, similar implementation, some differences. Let's look into other aspects, and I grouped it a little bit by things like deployment and network and scalability and reliability. I don't want to read everything here to you, but I try to talk about a few things that might stick out here. So first of all, if we think about the deployment or the complexity of it, RBD is fairly easy. You deploy your Ceph cluster and you're basically done for the server side. I mean, we might need a pool, but you need this for the others as well. On the client side, you have support in Linux, as long as it's not too old. There are third-party drivers for Windows. We actually, in the last few months, we have quite a few customers using that on Windows, and it works surprisingly well. And it is also well supported by many other technologies. iSCSI needs, on the server side, additional gateways, one or multiple as a cluster if we want to achieve high availability. They can be co-located. We've also seen deployments where customers are running them on separate hardware machines, so there might be some additional effort to set up additional servers and manage them. Also, there might be additional effort to deploy a multipathing configuration. On the client side, there is support in Linux and Windows. In Windows, very mature. It's also supported, thanks to Windows and Windows Server, by Hyper-V, and it's also supported by VMware, one of the usual block storage integrations we see in VMware. I will talk about how we see, or if we see, a shift from iSCSI to NVMe a little later. And it's also supported by a lot of other legacy systems. But it's a little more work to set it up, to get the configurations right, and to get it working. NVMe-of Fabric, similar to iSCSI, needs additional gateways. It might need additional steps to set up RDMA or do the SPDK configuration, especially the CPU locking / core pinning. It is well supported in Linux. The Windows support is still limited. RDMA is, I think, possible with third-party drivers. And there is a growing support among other technologies. CSI drivers are available for different platforms and technologies. But compared to iSCSI, it seems to be another layer of work on top of it. If we look at the network setups, it's mostly TCP. For RBD, that's very easy, standard IP, TCP, or we can run IP over InfiniBand. There is no real multipathing support, but given how Ceph works and how the client speaks with all the OSDs anyways, it's kind of every path support. So fairly easy to set that up. iSCSI uses TCP. There is, as far as I know, not really a high speed or high performance option except create a faster Ethernet. It supports multipathing, but that requires some additional configuration work, similar to NVMe-of Fabric, which brings RDMA as additional protocol as Rocky or InfiniBand, and it also brings multipathing support. If we look about the feature set, and I try to remove a few things that in our feature set view are already provided by Ceph anyways for all three of these. They support snapshots, they support cloning, they support dynamic resizing of volumes or loons or namespaces. Persistent reservations show some differences. Persistent reservation is a SCSI thing. Ceph handles that for RBDs a little differently with the high availability mechanism in Ceph and the fencing. For NVMe-of Fabric, we have NVMe reservations. High availability as a feature is kind of built in RBD, and for Ceph, for iSCSI and NVMe-of Fabric, it requires additional clustered gateways to be configured. In the compatibility section, and we already touched that a little bit, RBD is widely supported among different things. What sticks out here is that there is no direct support in VMware, and that as it's younger as many legacy systems, there is no great support in other legacy systems. But besides that, it's nice. iSCSI, on the other side, very well supported across legacy systems. It's, as an older protocol, it's not that great in modern infrastructures like container environments, but also very, very wide support for iSCSI. NVMe-of Fabric, as the youngest one, has a growing support. For example, VMware adopted it with vSphere 7, and I think updated it with the update 3, and I think TCP. CSI drivers for different platforms are emerging, so the support is growing, but it's not yet there where the others are. For example, Windows support is still limited. Windows Server 2025 is supposed to bring a native NVMe-of Fabrics initiator. Hyper-V is kind of dependent on Windows, so we have the similar support there as well. If we look into scalability, well, RBD scales very nicely. Client-side and server-side, just add more nodes, more clients, and the whole system scales nicely. We have that natively built into Ceph. iSCSI is kind of moderate. The iSCSI gateways are not that performant, but you can scale them, you can add more of them. Multipathing, load balancing is needed to make that work and helps. The gateways itself and TCP could be bottlenecks. They are not as performant as RDMA, for example. NVMe-of Fabrics is a little better than iSCSI. It was built for performance. It's more efficient. Also needs multipathing and load balancing. But overall, the performance scaling is quite nice. If we look to reliability, well, on the bottom side, we have Ceph, which is very reliable, and that works well for RBD. For iSCSI and NVMe-of Fabric, we need clustered gateways with a failover mechanism for the reliability. Already mentioned that multipathing is supported. The network tolerance, we had an internal discussion if these technologies are, if there's a difference between in these technologies, how they react to, let's say, less stable or less good networks. In the end, we said, okay, we're talking about software-defined storage. We need a good network anyways, so that is crucial for all these technologies. And especially if you look into NVMe-of Fabric with RDMA, which is like per definition a lossless network, that is fine anyways. If we look at differences that might be on the cost side, again, RBD is pretty much the Ceph cluster you already have. You might have additional costs on the other technologies. If, for example, for iSCSI, if you want to add fiber channel to access your targets differently, or if you need to change your network to support RDMA, if you need to add additional cores or memory or even nodes. So there could be additional costs for iSCSI and NVMe-of Fabrics. Security-wise, well, one thing that stuck out here to me is that iSCSI has no transport encryption, not as the other ones where this can be integrated with the technology by default, but iSCSI, this needs to be added with a separate mechanism, for example, tunneling it through IPsec or something. Besides that, they support different mechanisms for authentication, for encryption, and the data integrity in the end relies on the Ceph cluster anyways. So use cases, we tried a selection of different use cases, how these technologies can be used. It's always a it depends question. RBD scales very nicely, performance and capacity across growing amounts of data and clients. It is nice for virtual machines, for containers, for Linux native ads, for private clouds. We see it for backup and archive and a lot of different things. Virtualization and container support is nice. Mixed OS environments is something where it's a little limited. It depends on the driver support. Performance critical applications. Well, in this comparison, we say it's excellent, we know that outside the Ceph world, there might be other solutions that provide a different performance. You can store for big data or AI/ML, you can store large data sets, big training data sets. It's all wonderful. iSCSI is its primary workload. We see it with an integration in legacy systems. And for NVMe-of Fabric, we see it similar as a more modern approach to support latency-sensitive apps, especially thanks to the SPDK and RDMA options. But in the end, it depends on what you want to achieve, what your data set is, what your environment looks like. Probably one of the interesting questions here is, what about the performance of these three technologies? And there are benchmarks in the internet around that you can research. One thing that is probably obvious is that we add a layer on top of RBD by using iSCSI and NVMe-of Fabrics, and it's hard for this layer to make everything faster. So usually we expect iSCSI and NVMe-of Fabrics deployments to be slower than RBD. NVMe-of Fabric is more modern and more optimized for performance, so we expect that to be faster than iSCSI. And from the customers that we see that have deployed it or migrated from iSCSI to NVMe-of Fabrics, and also our own benchmarks, that's also what we see in real life. Usually the order is RBD is best in terms of throughput, IOPS or latency. Second is NVMe-of Fabrics. Third is iSCSI. But again, it depends. It depends on the workload, and we've actually seen a customer who had with using NVMe-of Fabrics a better performance than using RBD. But to be honest, they also had a very, very small data set they were working with, so there might be cache effects in play here. So we don't want to talk about only the differences or comparison, but also the challenges, and that is a little bit shaped what we see from integrating them into our solution, or also supporting customers with our solution, or just open source Ceph customers. Especially iSCSI is something where our engineers are not too sad not to see it around any longer. It seems like more prone to problems or instabilities. We are seeing stuck processes, TCMU runner and iSCSI gateways in weird states, and they seem to require some level of manual intervention or reboots to get them out of this state. We also have quite a few cases where customers have problems with iSCSI client blacklisting. Also another case that needs manual intervention. We don't see these kinds of problems among our NVMe-of Fabrics customers. Multipathing and high availability is something that seems to be quite complex to set up and to manage, especially in different environments or in heterogeneous environments. There is a problem with out-of-order writes, so usually we need to have these setups in a, what is that? What is that? Usually we need to have these setups in an active-passive configuration with multitasking to prevent out-of-order writes. And that is conceptually different from what RBD does or how RBD behaves, where the Ceph mechanisms handle that more tolerant for RBDs. The problem here is that iSCSI or NVMe-of Fabrics gateways don't talk to each other. If I have clients communicating to the same targets over different paths or different gateways, they don't know of each other. If there's a network problem, a latency problem, or something similar, there might be out-of-order data, and that could harm consistency. So active configurations, not a good thing. The client needs to handle the path switching, different mechanisms how to achieve that. And there's additional software necessary that might need to manage the gateway states and see who is active, who is down or out, who's disappearing or reappearing. And for example, for NVMe-of Fabrics to update the ANA group states, ANA asynchronous namespace access, I guess, if I remember correctly, to make sure that there are no inconsistencies in the data. That's another piece of software, these gateways. I think IBM for NVMe-of Fabrics has a similar approach with a daemon around it to manage that, but that needs to be managed and configured properly to make that work. So what do we see on the customer side? We have a few customers that already migrated from iSCSI to NVMe-of Fabrics, mostly customers using VMware deployments. And on the bottom line, they are generally very, very happy. It's stable, the performance is a little bit better, and it works just fine. What surprises us is that the adoption rate is not as we expected it. When NVMe-of Fabrics became a thing, we assumed that more customers would migrate faster to NVMe-of Fabrics from a VMware perspective, but it's pretty slow. And one thing that we learned is that many customers are just constrained by the vSphere version and have some update and upgrade backlogs internally that prevent them to migrate. We also see, and that is a more recent development, that some customers are not planning to do this change at all. Instead, they are also looking at other alternatives, moving away from VMware to other virtualization environments. So if we try a conclusion, which of these block storage options are the best, that's a hard thing to do. It depends. Now, the typical consultant answer, it depends. There is no clear one-size-fits-all solution. There are a lot of different factors that needs to be taken into consideration. So what is the environment a company or a customer is having? Are there any legacy systems? What is the use case? How does the network look like? What is the budget? Do I want to buy a new network? How much hardware do I want to buy? And so on and so forth. So it's very, very hard to give a clear recommendation. We are usually at the beginning of a project involved in understanding what the customer wants and then making recommendations. Our first choice is usually RBD. It's easy, reliable, and fast. It's good for a lot of things, but there are, of course, use cases when it's not working. If we can avoid it today, we try to not use iSCSI and bring customers on this technology because it's deprecated. We do see some customers every now and then adopt NVMe-of Fabrics instead. Okay, I think that's it. Thank you very much. Are there any questions? Thank you. Yes, please.
Which version of Ceph did you use to test NVMe?
At the moment, we mostly use Quincy and Reef for testing.
Okay, because there are many movements in upstream and will be in Tentacle as well.
So,
setting up the high availability and everything.
Yeah.
It's much easier. So
Yeah. Our engineering department is looking forward to that. That is one of the topics we are working most on at the moment when it comes to our deployment and management software, improving that part. Yeah, that's very good. Thank you very much. Any other questions? then thank you very much for attending my talk, and have a good rest of the conference.